Yeah, hi, good evening, everyone. So today is the week 7 open or summary session. Okay, before starting the session, if anyone have any query, because this coming week actually you have OPP exam also, so we have released one mock paper for the OPP exams. I hope you have you have tried to attend, and we have also released some tutorial type of video. So okay, so you can also just go through that videos. So then 20 video approx. Uh, what's this? Sachin Bharti? Okay. Hmm. Okay. So that video actually some problems are given, and so in video that we are providing the solutions of the problems. Okay. So you can just watch the video and just you can see how anyone can how approach the problems. Okay. So any query before starting the session for week 7? Because week 7 is also a part of the OPP1 exam. So you should know at least array part. Okay. So array part, you can expect one questions from array, basic questions. Okay. So you should know how we can implement the array, how we can traverse the array, how we can initialize the array. So the basic things about the array you should know for the OPP1. Okay, so do not skip the week 7 completely. Okay, for the OPP1 exam, at least just try to complete all the array part from the week 7. Yeah, Sachin, go ahead. Sachin, you are not audible. Sachin, you are not audible. Can you just try again? No, still not. You are not audible. So you okay? You can rejoin. Okay, and then try again. Yeah, Prithvi, go ahead.
Hi, good evening, sir. Is my voice audible?
Yes, you are audible. Perfectly.
Sir, is there any instruction to follow in OPP exam?
Instructions means. So
Means
actually,
some.
have you received any mails regarding the timings and all the things OPP exam?
Yes, sir. Yes, sir. Yes, sir.
Received, no? Okay. So the instruction is about to joining the meeting and set up your camera. This type of instruction maybe you have already received through the mail.
Yeah. And sir, in OPP we can use na copy and pen for something apply a logic something.
Yeah, you can use copy pen, but copy you can use some blank papers, not complete copy. Okay. So
Okay.
you can use the blank papers and pen, but you have to show papers to the proctor during the verification.
Okay.
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 Yeah. Do not use any different devices. Okay. So actually, proctor will monitor you. If you just used any other device, then definitely will caught as a plagiarism.
Okay, sir.
Okay.
Thank you.
Yeah. Just follow the all instruction given in the mail regarding the OPP. Otherwise, the questions wise, you will get the same interface like as your portal. Okay. And you have to complete 4 problems in 2 hours. Okay. And problems will be the on the similar pattern of the mock which we have released today. Okay. Like
Okay, sir.
first
Okay.
first two problems where you have to correct the code. You are from ES now.
Yes, sir. Yes, sir.
So for ES students, actually, you have to correct the code for first 2 problems. So first problem basically the some syntax error will be there in the solution, and you have to correct the code. And second problem, some logical error will be there in the code. Okay, you have to correct the code. If you are not able to correct the code, you can also remove the code and you can write your own code, new fresh code. Okay, but for
Means same pattern will be follow in OPP, na?
yes, same pattern. We have released the mock OPP at the same pattern, but questions will be different. Okay. So
Mm.
yeah, first two
Okay.
question basically the correct the code, and remaining two to come write the complete code. But for first two also, you can also write the complete code. If you are not able to figure out the error in the code, then you can just remove the code and write the new fresh code if you are able to write. Okay.
Okay. Okay.
Yeah.
Okay. Thank you, sir.
Yeah. Yeah, Sachin. Sachin, you are still not audible. So can you write in the chat? Not sure what happened. Any other query? Okay, so all of you just try to attempt the mock questions, okay, and also figure out the what are the basic syntax error you can make during writing the code, like missing the any variable initialization or missing the end symbol at the time of input reading, and missing the like a semicolon after the statement, like this type of basic syntax error. What are the possible syntax error? Just figure out this for the first question. Second question, for just logic error. Okay, so just you have to understand the problem, then you have to understand the solution logic, then you have to figure out the error in the logic, then you have to correct the code accordingly. And last two problems, you have to write the complete code. And the marking is also based on the your effort. So first two questions will be actually contains the 20% marks, and remaining last two questions will contain the 30 marks. Okay, so if you have attempt first two questions at least correct, then that means you will qualify, you are pass in the OPP exams for the course. Okay, so just try to complete all the questions, because the level of the questions for the OPP1 is lower compared to the OPP2 exam. So just try to pass the OPP1. Okay, do not escape, or do not just try to pass. Okay, just practice accordingly. And Week-7 is also part of the OPP, so do not skip the Week-7. OPP is or for all four subjects. No, no, no. So OPP exam is online proctored programming exam. So programming is only in C. Okay, programming is we are only using in C. So this OPP exam is only for C course, not for all. But yeah, some other course. So I think ES. This is the only course till now where the OPP exam is there. But later some other course may also come with the OPP exams. But right now you have only OPP exam for C course. Okay. So we have already released the mock, so you can just take the idea. So you will get four questions, and you have to solve the four questions in 2 hours during the OPP exams. I want to drop subject. I am not able to give time to complete the course. Sachindra. So I am not sure this is the time where you can drop. But regarding this, you can write to the support. So I think drop feature is available before the quiz one. You can drop before the quiz one, but not after the quiz one. But still, you can ask to the support. Yeah, so I think after quiz one, it is not allowed. Okay. Okay, then system requirement for OPP. System requirement, basically the basic system. Not we are not asking very hyper requirements. Okay, so the basic systems which are capable to open the browser. Okay, and because the portal will be open on your browser, and your internet connectivity should be good. So we are not asking to install any compiler or an editor in your system. So there is no specific requirement for that. But your browser should be running good. Okay, your internet connectivity should be good, or your that mobile. connectivity. So you have to also connect through the Gmeet through your phone. So that should also be in good condition.
Yeah.
Hmm. Yeah,
Yes, hello, sir.
yeah, Nirud.
Yeah, sir, when we will get to see the score of the time programming assignments?
Yeah, that is actually it will update in maybe next 2 3 days.
Okay, thank you, sir.
Okay, yeah, because this week 5 and 6 is still not completed now.
It got
So
completed yesterday. Yeah.
I
Oh
think
no, no assignment,
tomorrow,
assignment.
tomorrow.
Oh yeah, yeah. Okay,
Okay, so I think at the same time that timed assignment will also update.
okay. Thank you, sir.
Okay. Okay. Any preference for browser Chrome? So Chrome is, I think, fine. Which browser you are currently running for the course portal? If you are running fine, then you can use that. Okay. Okay. So then move to the week 7 content, because week 7 is also important for the OPP exam. So just practice for some questions based on the array. Okay. So we will not ask the questions based on strings in OPP1. So string part you can skip, but that array part is important. So just practice on the array questions. Okay. So let me discuss about the array week 4. Okay. So in week 7, if you have already watched the video, so we are discussing the some topics like array. What is the array? And another topic is pointer arithmetic. Okay, so how we can use some arithmetic operation on the pointers, and some strings. Okay, so strings related. What about the strings? How we can represent store the strings in our program? Okay, and what basic function we can use with the strings. But so we will start with the array. Okay, so let me open. Hmm. So as you know that when we are just writing the when we are solving the problem, so sometimes what happen, we deal with some problems where we need to store the similar type of data, but the data quantity is high. Okay, that means that till now what we were doing actually, we are just trying to solve the problem based on some simple variable data. So we are storing some information in some maybe one or two or three variables. But what happen if we have some more data? So like if you are given a marks of the students, okay, and that marks of the students we are giving for the 100 students. Okay, so we are giving the marks of the 100 student to you, and we want to find out that just return the maximum marks among all the marks. So at this time, so for 100 students, so you can think about that, if how you can store the 100 students marks. Okay, so one way is you can declare 100 variable, and you can store the data. Okay, for the each you can store the marks for each student's variable. Okay, so this is the one way. But what are the another way is possible? So suppose if we want to store the similar type of data, similar type of means, if we are storing integer. Okay, so that is integer. So that means we want to store the marks of the students, and each marks is represented as a integer. So this C provide a data structure. That data structure is called as a array. So we generally write this array. This is generally a list of similar type of elements, and similar type of we also use one terms, homogeneous type of elements. Okay, homogeneous mean similar data type of elements we can store. And the memory allocation happen like this. So suppose we are storing 10 data. Okay, integer, and 10 elements we want to store, and all elements will be the type of integer. So this array data structure provide a memory in that way. So the memory allocation will be allocated in the continuous manner. So like the first integer element is storing at the location like 60. Okay, 60 byte. You also know that the integer takes 4 byte. Okay, 4 byte. So next element, hello. Okay, so the first element is stored at the memory location like 60. So next element will store after the 4 byte, because the one element will take 4 bytes, so this take 4 byte. And next element will be stored at 64 memory locations like this. Okay, and so this is the second element, and similar way next element will be stored like a 68 memory address. So after 4 byte, so this is memory allocation will be happen in the memory. uh, if you are assigning a array data structure, if you are using a array data structure, so if you want to store 10 elements of the type integer, so this compiler will allocate 10 memory locations, and that memory locations will be continuously assigned. Okay, so in that way, and the first location, so this first location you can give some name for this first location, so that is called as a array name. So suppose if we are declaring one array, so what is the way of the declaration of array is like, first we have to declare the type of elements which we want to store in the array. Okay, so suppose we are writing like this int, so this is the data types of the array elements, and after that we will declare the name of array, so like a, and I'm giving the name of array, and after that we can define the size. Okay, so define the size in this square brackets, so like this. Okay, so when we are writing this, so that means we are declaring an array with name a, and size of that array is 10, so that means we can store 10 elements of integer data types. Okay, so ma'am, this a, actually a reference, we are saying that this is a variable. Now there is no need to create 10 separate variable to store this 10 data. Here we are just creating a one named data structure that is called as a, and that is pointing to the first address of the memory. And after that, if we want to access the second element, third element, fourth element in this memory allocation, so what we can do, we can simply add the memory location. So this first memory location is 60. If we will add 4 byte into this, then we can move to the second memory locations. Okay, and we can access our second data. Okay, same way, if we add 4 more byte into the previous, then we can access the third element in our memory. In this manner we can access all the elements, and we can perform any operation with all the elements in the array. So this is simply a how we can declare the array in memory, and after that how we can assign. So there is one term actually used with this data structure, that is called as a indexing. Okay, indexing, and this indexing, actually C programming use zero based indexing. So that means first element index is actually start with the zero index. Okay, this index will be start with the zero index, and this is just a identification. We can directly use this indexing to access the element, but internally some calculation will be happen to find out the address location. So that we will discuss later. Okay, so this is the zero based indexing for the array data structure. Second element will be accessed by the one index. Third element will be accessed by the two index, like this. Okay, so if we have total 10 elements, that means our indexing will move to like this: 0 1 2 3 4 5 6 7 8 and 9. Okay, 9 index. So 0 to 9, if you count this, so you will get 10 locations. Okay, so you are getting 10 locations, but the indexing will be start with 0, and it will move to till 9. So 0 1 2 3 4 5 6, and you can directly use this indexing to access the elements with the name of array. Like suppose if you want to access the element of this third element, so you have to use this index to access this element, and you have to write like this: A2. Okay, and you can simply read the value in this manner, and you can also change the value. So if you assign some value like 20 here, so A2 equal to 20, so this 20 will be assigned at this place. So in this manner, with the help of this indexing, you can access the all elements. Simply just change the index and you can access the all elements, but this name will remain same, A. Okay, this is the array name. So array name you can give any name. This is the same, contain the same property of the variable rules. So you can assign any name according to your program which you are able to understand, and you can just use this data structure to store multiple information with a similar type. And after that, this so there are many problems create based on this type of data, where some large data is given to you and some information is asked about the data. So in this week, actually, we are dealing with this array topics, and our problems are also based on this array topics. So now we will check how we can declare the array and how we can access all the elements. So like this, and after this, we will also discuss the pointer arithmetic with the help of array also. Okay. So how we can use the pointer for the array and how we can access all the elements using the pointer. So basic program, I'm writing this like creating the array, reading the element of the array, and printing the element of the array. Okay. So like, so include. So this is the header, and after that, we'll write the main function. So int main. Okay, so suppose we want to store 5 elements. So what are the way we can initialize the elements, and we can write the store the elements in the array. So suppose if I'm declaring one array here, so integer type, and array name is A, and I'm writing only 5 elements for the example. So this is the first thing. uh, I've declared the array, and after this, what we can do, we can assign the elements by the indexing. Okay, so what we can do, we can write like this. So A0 equal to 1. Okay, so in the each line we can initialize the elements like this using the indexing. So 0, 1, and 2, 3, and 4. Okay, and like this, 2, 3, 4, and 5. Now you know that indexing is starting from 0 and it is moving to till 4. Okay, because we have just declared the size 5, so we can store the 5 elements in this. And now if we want to print this, so how we can print this? So we can use the for loop for this, and inside the for loop we can take integer variable that will start from 0 and it will move to till 5. So like integer I, or we will use inside the for loop. So for integer I equal to 0. Okay, and what is the condition we will mark here? So I is less than equal to 4, or we can write like less than equal to 5. So this is the index range we have for the array, 0 to 4, and every time we will increase this index by 1. Okay, and inside this we will use this index, this I variable as an index in the array. Okay, so we will write like this. So print f, so percentile d. Okay, and array name, and we will pass this integer variable as an index of array. Okay, and so you can see here, this is we have declared a small a name for the array, so we cannot write capital A here, so we will use the same small a. And this is yeah. Or we can just use the new line character to print all the elements in new lines. Okay, so now this is the code we have written here. So you can see we are accessing, so this loop is running, and initially we are passing I equal to 0, so this I is replaced by 0, and a 0 element is printing, which is actually 1. Okay, and similar way we are incrementing the I is become 1, then here I will change replace by the 1, so a1 element is printing. So in this manner we can access all the elements using this indexing. Okay, 0 to 4. So this is the one way we are initializing the array by indexing. Another way is we can initialize at the time of declaration. So that is actually by this way. So we can pass uh, like this 0, sorry, 1 comma 2 comma 3 comma 4 comma 5. Okay, so this is also one way to initialize the elements in the at the time of declaration. So we have declared the name of array and size, and after that in curly braces actually we have assigned the elements. Okay, so 1 2 3 4 5, and so these all these elements will be stored at the index, corresponding index. Okay, so this one will be stored at a0, 2 will be stored at a1, and the behavior is same. You can see we are getting the same input as previous, 1 2 3 4 5. Okay, here suppose if you missed like this, so 1 2 3, so what will be the value of the all 5 places? Okay, so we are assigning only 1 2 3, so 1 will be assigned at 0 index, 2 will be assigned at 1 index, and 3 will be assigned at 2 index. Okay, after that we are not assigning the value. So what will be the output? You can see 1 2 3, but last remaining value is actually 0. So by default, if you are initializing any one value at the time of declarations, so remaining place which you have allocated for your array, so that will be initialized by 0. But if you are not initializing by any value, so some junk value, previous junk random value will be available at that location. So that some junk value will be printed. Okay, so you can see at the first place this value is printing, and remaining is all 0. So if you run this, so similar type of behavior we are getting, but this is some junk or random value we are getting here. Okay, but if you initialize by only single element like 1, then your value will be all like this. So 1 is assigned and remaining are zeros. So this is the some behavior difference in the different compilers. So in the previous case, when we are not initializing, we are getting some one random value and remaining are 0. So this is not always true, because in some compiler you will get all random value, all junk value. Okay, so at the all place. But if you initialize only one variable, sorry, on one value, then all remaining value will be initialized with 0 by default. Okay, so this is the compiler, this is the compile time initialization. When you are writing the code, you have also initialized the value to the array, and you are printing this. And what are the another thing is how we can read this array elements at the runtime. Suppose runtime means when we are running this code, at that time how we can store the elements in the array. So this is also one common things, so that we can do. So similar type of things, we want to store 5 elements at the runtime when we run this code, and then at that time we will read the input value and we will store all value uh, at the runtime. Just give me a minute, just put the charger. Okay, so now how we can read the value at the runtime. So for to store the value at the runtime, again we have to run a loop, because we have to read the elements one by one, and we have to store all the value at the correct place. Okay, so here we will just run a another loop like this. So for like same int I equal to 0 and I is less than 5 and I plus plus. Okay, so this is the range of our index 0 to 4, and inside this what we can do, we can simply use the scanf. and inside scanf, what is the type of element, and after that we will pass array name. So that is the same, a and I. Okay, so we will use and symbol here. So in this way we are reading the elements. So how we can read the elements? So now you can see, so this loop will run 5 times, so we will enter 5 value for this. So like 1, enter 2, 3, 4, and 5. Okay, after that another loop is running, so you are getting uh, the same value 1, 2, 3, 4, 5. Okay, and the similar way you can also pass the value like this by the space separated. So 1 space 2, 3, 4, 5. Then it will read all the value one by one, and it is printing all 1, 2, 3, 4, 5. So this time we are giving the input, and we to the array at the run times. When we have run the code, at that time we are passing the input value, and that value are stored in the array locations using this first for loop. Okay, so for loop means we are running this loop. So I equal to 0, so this become a0, and at this location we are reading the first element, and that first element is stored at this position. Okay, so in this manner all elements will be stored after. So this loop will complete, and after that second loop we will run, that will print actually the same data again.
Sorry, for loop runs 6 times then.
uh no, so
And
this
if
huh
and if our array is just 5.
no, why no? So this condition is, you can see, this is less than.
Uh-huh. No, yeah,
Okay,
if we increase that number 5 to 6, then
so that is actually will run. So actually we can do this, but it is actually our compiler will not give any error for this. But sometimes, because we have only in get this memory locations. Okay, so we have just get only memory locations for 5 elements, so a0 to a5. But if we are accessing the next element after that, so C will that compiler will not give any error for this. But this is actually risky, because that memory locations is not allocated for our program. So maybe you will get some random value, or you will get some sometimes your program may be crash, because you are accessing the memory which is not allocated to you. Okay, so just
okay, sir.
yeah, keep this thing in mind. If you have allocated some size for your array, so just use that size locations. Do not access those locations which is not allocated to you. Okay, suppose if we run this, so this will ask to the like this. So 1, 2, 3, 4, 5, 6. This is running 6 times now, but our code is printing 5. But if we run this like 6, so it will work, but sometimes it may also crash. 1, 2, 3, 4, 5, 6. Okay, you can see we are getting 1 to 6. This is happening because the next location is free. Okay, so maybe our another program is not using that location, any other program. So this code is actually accessing that location, and it is updating the value at that location, and you are reading the value. But this is not secure. Okay, because compiler is allocated only the 5 locations for your program, so do not access more than that. Okay, so yeah, this is the one thing. And another thing is, we have declared this, so we should also write return 0. Okay, so this is the one thing. So now the questions may be asked like this. Some array is given, and ask we can ask that, like what is the maximum element of the array. Okay, your program should return the maximum element of the array. So suppose we are passing some element, like here we are giving 5 elements. So let's correct it this. Okay, at the input time we are giving 5 elements to the array, and that elements are stored in the array, and these elements are not in the increasing order. Okay, we will just pass the random order to the. So just find out the maximum element in the array. So how you can find the maximum element in the array? So this is the one problems may ask. So like this, what we are doing, we are just passing some random element 4, 7, 2, 9, 1. Okay. Out of these, what is the maximum element of the array? You have to find. So how we can find this? So what we can do, we can run one loop, or we can initialize that. Like we can initialize one variable int max. Okay, max equal to a0. Okay, you can simply assume that first element is the max element. Okay, so we are just assuming that the first element is a maximum element. After that, we will start from the second element. Okay, so we are reading as a second element as, to the compare. Okay, and we will just read the second element from the array, and we will compare that element with the current maximum element. If our this element is a greater than the current maximum element, so we will update our max value. If not, then we will ignore. Okay, so inside this, what we will do, we will just take this condition if our a, okay, so a of I, here we are reading the I index. So if of I is greater than, okay, a of I is greater than max. Okay, if this condition is true, then we will change our max equal to a of I. Okay, so now you can just try run this. So here max a0, so a0, for example, we are passing 4 as a this as a input list, 47291. So four element will be assigned to max first. After that, we will compare, we will start comparison from 7. Okay, so here 7 is greater than 4, yes. Okay, if yes, then we are assigning max equal to current ai a1. Okay, so 7 will become max. Then we will move to the next iteration. So now I become 2, that means second index, so this is 2. Again we will check this condition, so 2 is greater than max. This time no. Okay, because max is now 7, so this condition will not be satisfied, so this loop will iterate without doing anything. So next time we will check with 9, so 9 is greater than max, yes, 7. Okay, so this condition is again true, so our max become 9. Next iteration we will check with 1, so 1 is greater than 9, no. So after completion of this iteration, your max is now contains the maximum value among all the values. So now print the element max. Okay, so like same input we are passing here, so 4 7 2 9 1. So you can see we are getting 9 output. So this type of problems maybe ask like this. So here this is the max, and similar type we can ask the min. Any problems? So suppose one of the problem is given in the practice assignment is like one random elements are given in the array. You need to sort the elements in increasing order. So you can apply some logic to sort the elements. So what sorting is also actually very important to solve some problems. So how you can sort the elements, so I'm just explaining some concept of the sorting. So there are many algorithms, but for basic you can apply some basic algorithms which is generally called bubble sort and selection sort. I'm just explaining the concept of this basic algorithm for the sorting. Suppose our list contain like this 7 3 5 4 2 1. Okay, so total 6 element we have. So our array of size 6 contain this order. Okay, so this is the 0 index, this is 1, this is 2 3 4 5. Okay, above 1 is the indexing, and these are the elements. Now how we can sort these elements? So we can sort means at the same location, so location same array, we will sort the elements. So that means smallest element should come at the first place and the largest element should come at the last place. So order should be in increasing order. So how we can do this? So I'll just explain the selection sort. So selection sort algorithms, actually how selection sort works. So we will just pick the index first. Okay, we are just picking the index, 0 index. So after sorting, so you know that after sorting, what should be the output? So output should be 1, 2, 3, 4, 5 and 7. Okay, so 0 index, 1, 2, 3, 4, 5. So this is the sorting order. So after running the algorithms, your output should become like this. Okay, at 0 index, this one should come, 1 index, this should come. Okay, in this manner output should come. So that means what we can do, we can run a loop. So we have already run one program to find out the max. Okay, similarly we can also write a program to find out the minimum, in all elements. So if we run that program to in our entire list, suppose we are looking for the elements for 0 index. So for 0 index, that means smallest element should come at this location after sorting. Okay, at the first place. So what we can do, we can run the algorithms to find out the smallest element in the complete list, complete array. Okay, so complete array means in this complete part, we will run a loop and we will simply compare all the elements one by one, and we will find out that what is the index that contains the smallest element. Okay, that index that contains the smallest element. So same things we can do, we can just assign min equal to 0 index. Okay, initially we are just assuming that 0 index is a minimum element. After that we can run a loop from 1 to 5 and we can simply compare the elements one by one. Okay, so if this one index element is smaller than the min elements, that we will replace, otherwise we will skip. Okay, so here we can perform this process. So in this manner, so we can take two pointer I comma j. Okay, so I will always point the current position where we are looking the elements. Okay, so what are the index? For this index we are looking the correct element after sorting. Okay, and this j loop will just iterate all the elements one by one and will just find out the smallest element. So in this process, after comparison, so we are starting from 7. Okay, so 7 is we are assuming that this 0 index is the smallest element, that means 7. Okay, so 0 is representing the 7 element. Then we will move to the next element, 3. Okay, so this is the index 1 element. So 3 is smaller than 7, yes. Okay, so we will update our min to like 1 index. Okay, this is indexing and this is the value at that index. Okay, so that means this is 3. Now once again we will move to the next element. So 5 is the smallest to min, no. Okay, 4 is the smallest to the min, no. 2 is the smallest, 2 is the smaller to min, yes. Now again we will update our min equal to now fourth index. Okay, and value is 2. Now next is 1. 1 is smaller than the current min, yes. Okay, so once again we will replace it. So that means 5 index and value is 1. So all elements are completed. Now you find out that our I is pointing to the 0 index and we have compared all the element, and finally we have find out that what is the actual smallest element in the array. Okay, so this is the 5th index. So what after running this iteration, what we can do, we can simply swap the value of this current I location 0 and what is the minimum index, 5. Okay, so minimum index is 5. We can swap the value of these two index only. Okay, so for swapping you can simply take some temporary variable and read the value. This is similar to the swapping of two variables. Okay, you have already done this program in previously. So after swapping this, so our array will become like this. This 1 will come at the correct position. Now this 3, then 5, 4, 2, and this 7 will move here. Okay, now you know that in the first iterations this part is sorted. Now same process you can apply for the second index. Okay, this is the 0 1 2 3 4 5. Now you consider that this is the part where you have to work, because this element is now correct position. So same process we will repeat on the remaining part. Now we will assume that this is the minimum element, and we will compare all the elements to find out the minimum elements. So now our eye is pointing to this, and we will repeat this process. You can see 3 5 4 2. Now after completion of this iteration comparison, you will find out that this is the minimum. Okay, this is the minimum. Now swap this 3 and 2 in this process. Okay, so then you will get like this 1 2 5 4 3 7. Okay, 0 1 2 3 4 5. So indexing will remain same always, we are just changing the elements. After that, now this part is already done, so we will process only the remaining part, this. Okay, so same things, we will point to this index, and we will find out the minimum index. So minimum index, minimum index means minimum value index. So this is the minimum. Okay, now we will swap both. So in this manner we will repeat this process. So 3 4 5 7. Okay, so now again you can see this part is completely sorted. So we will repeat this process for the all index, so like this and this, and after that you will get the sorted list 1 2 3 4 5 7 finally. So you will get the sorted list at the same array, in the same array. So this is one sorting algorithms. Another sorting algorithm, this is called as a selection sort. This is very basic. And another sorting algorithm is bubble sort. Okay, so similar like in bubble sort 735 3 5 4 2 1, like this. Okay, so suppose this is the input array, we have a6, and this is the indexing 0 1 2 3 4 5, like this. So what we will do, we will run the so how many elements we have? Total 6 elements we have. We will repeat the same process 6 times. Okay, so 6 times. So how many elements we have? 6. So we will repeat this process 6 times. And what is the process? So we will simply compare the elements of the each uh, adjacent elements. Okay, so suppose we are looking for this and looking for this. Okay, we will check the order of these two elements. Okay, we will check the order of these two elements. So in sorted list, smaller values should come first, and greater value should come after that. So for each individual adjacent value, we will just check the order. If order is not correct, then we will change the order of these two elements. Okay, so this is the one process. So we will do this like, okay, so 7 and 3. So we will, this is not in the correct order, so we will change this 3 and 7. Okay, 5 4 2 1, and same process we will check for the next element. Okay, 7 and 5. Now we have done this with the two elements. Now we will shift these things to the right. So 7 and 5 not in correct order. Okay, so 3 5 7. Okay, 4 2 1. Now same we will check for the next. Okay, 7 and 4, this is also not in correct order. So 3 5 4 7 2 1. Now this part. Okay, so 7 2. So 3 5 4 2 7 1. Okay, now last is this part. 3 5 4 2 1 7. So in this process what happens, so this is only one iteration, this is the one iteration, we have to repeat these things 6 times. Okay, now in the each time one element is actually shifting to the correct place. So you can see this was the biggest element in the first iteration, that is actually shifted to the correct place after this one process. Okay, this here. Now we will repeat the same process again. So second largest element will shift at the correct place. You can see if we will check for this. So now this is in the correct place. Okay, so 3 5 4 2 1 7. Now this, yeah, this will update. Okay, so 3 4 5 2 1 7. Now this one, once again this will update. So 3 4 2 5 1 7. So now next this is this one. So 3, 4, 2, 1, 5, 7. Now when we compare this, so this is already in correct order. So in second iteration, we are starting from the same things, and 3, 4, 2, 1, 5, 7. You can see now two elements are coming at the correct place after two process. So if we will repeat this process total number of elements times, so in each time one element will come at the correct place. So total we have 6 elements. So that means all 6 elements will come at the correct place after 6 iterations. So this is called as a bubble sort. Bubble sort means we are just comparing the each adjacent elements, and we are correcting the order after swapping the elements if not in the correct order. Okay, so this concept you can apply if some array is given in the unsorted order and you need to arrange the element in the sorted order. So these are basic two algorithms for the sorting you should know. Okay. Okay. So this is about the sorting basic thing. So just you can implement one of the algorithms, either bubble sort or selection sort. So let me just implement one algorithm, bubble sort or maybe selection sort. Okay, so we will just pass the same input, any random input for the array, and we will read this. And now how we can sort the list. Okay, so to sort the list we have to actually use the nested for loop. So one for the I, so in each we will use this I0 to I, yeah, this is the fine 0 to 5, and inside this another loop. So for int j equal to 0 and j is less than 5 and j plus plus. Okay, and yeah, this is already there. Okay, so I'm just updating this. So this is the two loop we have run, right? We have written. Okay, so after inside this loop, okay, so that means for I equal to 0, we will run this complete process. Okay, so this loop will run completely for one single value. Okay, so I equal to 0, this will run completely. Then next for the next value, this will again run completely. Okay, so that means this is defining the number of iterations of the process, and this is actually for the process. So here what we are doing, we will just compare the elements. Okay, yeah, we have to run because we are starting from I equal to 0, so 0 and next element we will compare. So there is no need to move till last element. So what we can do, we can just take one less, because during the comparison we will consider that for the comparison. So what we will do, if uh, elements, okay, so a of j, okay, so element at the j index, if that element is greater than, okay, if that element is greater than of a j plus 1, so I am just implementing bubble sort here. Okay, so that means aj and aj plus 1, so j plus 1 is the next element. So if first element is greater than the next element, so that means that is not in the correct order. So in that case we need to swap these two elements. So for swapping, what we can do, we can just take in temporary variable. So in temp equal to, we will read one value here, so aj. Okay, now aj value we have already read. Now we can just update the aj value, aj equal to aj plus 1. Okay, and now aj plus 1 equal to, this is simple swapping of two locations and temp. Okay, So this is the process. So every time we will check aj is greater than aj plus 1. So aj we are just moving to till 3 index. Okay, so 3, when we are taking j equal to 3, so that will compare with aj4. Okay, so that a4, so that 4 is the last element because there's no element after that 4. So because of that we are running till less than 4. Okay, so after that we will just swap this, and again this what we will do, we will print the same array after this process. Okay, printf and ai. Okay, so you can see we are just using the same indexing 0 to 5, and initially we will pass some element here. So let's see we are getting the correct output or not. Okay, like 4 3 5 6 1 random. Now you can see we are getting the 1 3 4 5 6 by this loop. Okay, so there is no space coming. So again you can see, so you can see elements are coming in the sorted order 4 5 5 6 8. So this is called as a bubble sort, and similar way we can also implement the selection sort. So any one sorting algorithm is fine if you know that sorting algorithms, because in the C programming course we are not just comparing the algorithms time or these things, so you should know at least one sorting algorithms, one sorting process, how we can sort the elements. Okay, so this is the some array uh, applications. So how we can use the array, so similar type any problems maybe arise, so you can just access traverse the array and perform your operation by the indexing. Okay, any question in this array part, basic? Okay, so okay, no query. So similar type of one question is given like reverse the array. Okay, reverse the array, and I think the sorting questions is also given in the grading questions, so you can solve by using this algorithms. Okay, and next thing is the arithmetic of pointer. So pointer you already know, we have already learned in the previous week. So what is pointer? Basically pointer is just a variable, and we generally declare like this. So int, suppose we are writing a pointer for int p. Okay, and so that means we are declaring a pointer p. Okay, so this is the name of pointer. Actually it will contain the address of integer elements. Okay, so pointer is just a variable that contain the address of another variable. Okay, so how we can perform the operation with the pointer? So that means same things. Now we have already see the array things. So in terms of the memory, so if we are declaring some array like this, so a5. Okay, so how we can just read the address in the pointer of this array, and how we can access the elements. Okay, so indexing means, so what actually how indexing is working basically. So this a is actually a itself a pointer that contain the address of first memory location. So I have already mentioned that this contain the address of first memory location. Okay, like this is a 60, this first address is a 60. So and we are taking like this int. Okay, so now this is integer variable, so this will become a second element will become 64, then 68, then 672, then 76. Okay, so like this, so 2 3 4. Okay, so this is the zero indexing, so this is 0, this is 1, this is 2 4. Okay, so this is 4. So how we are actually calculating this indexing? Suppose if we are using this a 3, so that means we can also write like this. So uh, a address, okay, this is the address of first pointer plus, and we can write like 3, okay, 3 into size of int. Okay, so this a is actually a pointer, okay, that contain the address of first location, so that is actually a contain the 60. And when we are using this indexing, so a3, so that means we are multiplying this 3 into the size of the array. Okay, so this is actually called as a size. If your array is integer array, that means it contains the integer elements, so we will multiply by the size of int. If suppose if our array is a character or a sort array, okay, so like sort a5, okay, in that case if we are writing a3, okay, so you know that sort takes actually 2 byte. Okay, so this will become like this plus, so 3 into size of sort. Okay, size of sort, and size of sort is actually 2, so this become 2. And suppose this a equal to 60, so 60 plus 3 into 2, 6, so 66 will become the address of this a third element, third index element. Here size is 4, so 3 into 4 12, 12 plus 6 60 is 72. So now a3 address, actually this is the 72, this location. So indexing is given in this manner. So first element actually, so we can also say that a is also pointing to the 60, and if we are saying that a0, that is actually also pointing to the same starting address. Okay, both contain the same memory locations, 0. And this is also correct because a plus 0 into size of int 4, so you will get the same address, okay, 60. So a0, that means first element, or simple a, this is also a first element pointer. So we can use this pointer arithmetic. So after getting the pointer, we can perform some arithmetic operations on the point with the help of pointer. So let's just discuss about this. Okay, suppose we have this array and we have some element initialization like 1 2 3 4 5. Sorry. Okay, now if we are declaring some pointer like this, so int hashtag p, uh, int hashtag p, and that is actually contain the address of a. And with the expression of int hashtag p. Okay, so we can simply write like this. Because this a is also a pointer, okay, name of the array is also a pointer, so we can directly assign the value. So let me just print the address of both field. So what value we are getting, so like printf percentile this p, or you will take the both. Oh, this is inside long. integer. This is long integer. Okay, let's just try with you. Okay, so we are getting some here integer value. So you can see both have the same address. Okay, so P, and we are assigning A to the P. Okay, so A contain actually the address, this address in the form of integer. If we can also print as a X, so that will come as okay, this is dot. Oh, sorry. So let's So here we are getting the same address in the hexadecimal. So 8080, you can see we are getting the same. So now suppose if we just add one in this pointer, okay, so a plus one. Okay, so what actually we are doing, we are performing some arithmetic operations with the pointer. So this a is actually a pointer a1, and we are assigning this address to the pointer p. And if we write like this a uh, here one, so let me check. This is actually between the two. No, you cannot write like. Okay. Okay. So we can, what we can do, we can just write a, so a0. Okay. So what we can do, we can just write the address of and symbol a1. So now you can see. So when we are adding one, so this is simply, you can see, arithmetic operation. So we are adding the one value into the pointer. So this a is a pointer. Okay. So what we are getting, so here this one value is not adding into this, okay, address. What adding actually, the element of the actually one element size. So here what will happen, what is the current address of a, if we are adding 1, so that means it will add the integer size, one element integer size to this pointer, not the value 1. Okay, so this value will not be add, so the operation will be performed in that way. So one element integer size will be add into the pointer address, so that means 4 byte will be added into the address, because the first element address, if you will print the first element address, you can see uh, we can report like this. Okay, so this is a0. So now you can see we are getting 20. Okay, after adding this a plus 1, we are getting the new value in the pointer p. So that is actually a address after adding 4 byte. Suppose if we add 2 in this, so that means 2 elements address will be add. So here is this p, because we are just printing this p address, we have updated a plus 2, but this is actually a1. So our pointer is now containing 8 byte more than the first address a plus 2. So 2 into int size. In this manner the operation will perform. So we can perform this type of arithmetic operation to move to the next location in the array. Okay, and after that we can print the element also. So here we are just moving to the a plus 2, that means the second index element, so we can also print the value of that. So using pointer we can also access the elements. So like this, what we can do to print the element, what we can do, we can simply use the dereferencing. So dereferencing means asterisk, and here we will use the percentile d. Okay, what is the element at this location? So when we do this, so now you can see address of this p is now 48. Okay, first address is 40, and we are just moving to the second index. Okay, so this is 0 index, this is first index, and this is second index. Okay, and now this value is printing by this pointer. So p asterisk 3. Okay, so you can access the elements by the pointer itself. So you can simply perform this operation repeatedly, and initially suppose this is the size a, then here you can perform this. So like p uh, plus 1. Okay, if you're writing this, so you will get the second element 2. Once again you can see, so p is the first element, p plus 1 will become the second element. Okay, so next address, and if we will change this p plus 2, then we will move to the next location. So this is the different way in the with the pointer arithmetic. Okay, so if you will just change this p plus 3, now you are getting the fourth element, this one. Okay, so in this manner you can access the element simply. So this is the addition operation with the pointer, so we can add the value, but that value will be add after the multiplication of the integers, that arrays type of the element size. Okay, not directly in the pointer. Simply we can also use the increment and decrement operator. So here this is the actual first size, first address of the array. Okay, when we are writing p plus plus, so let's see what we are getting. So we are getting 1 because this is the post increment operation. Okay, let's just do this pre increment. Now you can see, so when we are writing plus plus p, so this is the increment operation. Okay, increment by 1, and this is if we are using before this p, that is pre increment, because after increment then we will read the value at that place. Okay, if we are using the post increment, that means first we are reading the value at that place, and after that we are incrementing the pointer. So that means we can also do the pre increment, this increment operation and decrement operation. So suppose if we are assigning some value like plus 2 here, and if we are using this decrement operation, okay, so that means a plus 2 means the address of 3 is assigned to pointer p, and now we are using decrement operation, so we are accessing the next just before element. Okay, 2 by this decrement operator. So we can also do this operation with the pointer, decrement operation, increment operation, and addition operation and subtraction operation also. Okay, same things we can write like this. So p minus 2, p minus 2, so you will get the uh, first element. Okay, so here we have added 2, that means 8 byte into the base address, and we have reduced the 8 byte from the pointer p. Okay, so this type of operation you can do, and you can access the memory, access the array using the pointer also, without using this array name and indexing. You can directly read the value. So suppose if you want to print all the elements of the array using the pointer, so what you can do, so like you can run a loop for I int I equal to 0 and I is less than 5 and I plus plus. Okay, and inside this what you can do, print f and percentile d, and after that simply using pointer. Okay, so p, we have initialized this p by the first address, okay, here at the top, and after here we what we can do, we can just write like this inside the bracket p plus I. Okay, st, this is new line character. Now we are removing this. Okay, so using pointer we are printing the elements without array. Okay, so here this operation is similar to your indexing operation. So base address plus 1. So if you are doing base address plus 1, that means base address plus 4 byte. If base address plus 2 means base address plus 4 byte, and we are directly getting the address of the corresponding element. Okay, so this, because of that, this is a constant operation. So first we are calculating the address of the particular index element, and then we are directly accessing that element without traversing the all elements in the array. So this is called as a arithmetic operations. So what this type of operation we can do, and one more operation we can also use the comparison operator with the pointer. So how we can do this? So suppose just check how we can compare the pointers. So let's this is a pointer where we are assigning a, and the another pointer I'm writing that like this. So int asterisk q equal to a0, and this a0 will be right like this using the end symbol. Okay, now p and q, first we are assigning the address of p a directly, because this a is also called as a pointer, but this is referring to a index. Now this completely referring to a variable, so we have to get the address of this location by using the end symbol. Okay, so for this now we can compare this. So like int z equal to uh, and we can take this condition, or what we can do, we can write like the if statement. If p equal to q, print message same address. Otherwise, so if we run this code, you can see we are getting the message same address. So that means this condition is now true. P and q both are same. Okay, because both address are same a0, so we are get this condition become true, and this message is now printing. Suppose if I write this one, so then it become a false condition, not. Okay, so we can also compare the pointers. If we have two pointer variables, that means we can also compare, and so we can also compare our pointer with null. Okay, there is actually null is also stored as inside the pointers. If we are storing the null into the pointer, that pointer will become null pointer. So we can also compare this pointer value with null. Okay, this value null. Suppose we have initialized our variable with null, and some process at some times our pointer is initialized with null, then we can also check this. Okay, suppose here we have declared like this, so null, so that will also become true. Okay, so this is now equal to null. So null means no address, nothing. Okay, so null is the just a empty value. So this is the specific value to assign some. If you have no value to assign, okay, you can assign null. So this type of operation you can perform with the pointers. So this is useful in some case. So when you're dealing with the array sometimes, okay, and when you're writing the functions, so sometimes the address of the arrays will be passed to the function, and you can perform some operation directly using the pointer. Okay, any query in this pointer arithmetic? Okay, so some questions are given like this PPA. So as I have already said that at least complete the array part, okay, array pointer arithmetic part for the OPP exam. So string part is not important for the OPP one, so you can complete that part later also, but array is important. So simple. So in this question, simply we are just passing the input size 2 and reading the 2 value and printing the these two value and addition of these elements. Okay, simple. So I have already mentioned that how we can read the elements from the user and how we can print the elements. Okay, so here we are using the simple print statement by some space, and we have to also perform one operation to sum. We have to read all the elements one by one, and we have to add all the elements. So this is basic simple operation. Another questions is sort array. Yeah, this question I have already done. You can apply any sorting algorithm. So 6 is the size length of the array, and these are the elements in the array, and this should be the output. Okay, so you have to write the function in this manner. So what happening, you need to write this sort array function where you are receiving the array and size of array, and you have to perform sorting process, and in the main function actually we are printing the same array. Okay, that means output array should be printed in sorted order, and here it is written that the function does not return anything. So that means sorting should happen at the same array, so no need to create new array or like this. So PPA3 also is increasing decreasing. Yeah, so you can see here some scenario is given like 1 2 3 5 6. So till now the array is actually increasing. After that this is uh, this is not decreasing because it is asking for strictly. Okay, so strictly means strictly increasing. So every element should be high. Okay, every next element should be high, or every next element should be low in the decreasing part. So here this part is okay because each elements are increasing order. Okay, so 1 2 3 4 5 6. But here in the next part you can see 6 to 2. So 6 to 5 is fine, but 5 to 5 is same. Okay, it is not decreasing. So in this manner that means this is not correct. So here output is -1. But in the next things you can see 1 2 3 5 6, and then 6 5 4 3 2 1 like this. Okay, so we are getting the correct process. So this till now our elements are increasing. Now in this process our elements are decreasing. So this is the point actually where the first part is actually increasing part before that, and after that decreasing part. So what is asking, okay, this point. Okay, so if our list is in the correct order, just find out the peak point. What is the index of peak? So index of peak element is, peak means max, 0 1 2 3 4. That means our max element is at the fourth index. So if order is correct, then return the max element. So here you can just apply the same loops and just check elements. Or what you can do, you can also find out the max element first and check the element before the max elements are actually in increasing order, and after that decreasing order. So you can do in this manner also. Otherwise you can use the two loops first to check this part. Once you find out that this after 6 you are getting decreasing, you can stop the first loop, and after that repeat the same loop from the second part. If both loops are satisfy the condition, then you can return the result. Otherwise you can return the -1. So here you can apply the logic for this question, this type of. Okay, so okay, the next part is actually string base. Okay, let's see, next is string. Yeah, so string is also a there's no direct data type for the string, so we cannot directly store the strings in some data type. Actually string is stored as a array. Okay, so collection of elements, that means string is a collection of characters, and these collection of characters we can store inside the array also. So what we can do to store the strings in our programs, so similar type of array, we can what we can do, we can assign like this hello message directly. Okay, so now you can see 5 characters int a. Or we have to define this array like char. So we have to create some array and we have to assign some size for that, so that size should be greater than the length of the array. Okay, so here suppose if hello world, if we are writing like this hello world, so it is showing some warning, initialize strings for char array is too long. Okay, because we have assigned the size 5, and but our uh, string is higher length. So if we write like this 15, then it will work. Okay, so in this manner you can also store, and after that you can print the character by character using the same indexing things. Okay, so for loop for like int. So for indexing we will use the integer variable I equal to 0, and after that uh, I is less than equal to 15 or 14, I plus plus. Okay, now if I'm printing the same array, printf percentile C. Okay, this time we will use the C for character. So now A indexing I. Okay, so if you run this, you can see we are getting the hello world. These things. Or what you can do, you can also print using the string specifier directly. So in this manner, if you're writing these things using S, and just print the complete array A. So this is also slash n. So you can see we are directly printing the hello world. So this is actually for printing S specifier. So what string is stored in this array, it will print completely. Okay, hello world. Otherwise you can just run this loop and you can print the elements. But I think some slash n, if I do this, you will get the empty locations. Okay, so what happening actually, so you can see how many characters we are using in this string. So 1 2 3 4 5 first. Okay, then this is one character empty space, 6 7 8 9 10 11. Okay, so when we initialize any strings to the array or any pointers, so after last characters, actually by default that one terminate characters, we generally say that slash 0, that is also stored in the strings, and that is actually a identification of the termination of the strings. So here if we print this percentile C, this is actually a 10th character. Okay, so 10 C10, sorry, A10. Okay, so what is the A10 character? D. Okay, so this is the last character, but after that one more character will be assigned, that is actually termination character. Or if we just try to print, let's see if it is showing or not. It is not coming, but one empty space is coming. So that is actually a termination symbol. That is so compiler can identify that because we have assigned total 15 character. Okay, but we have initialized a value with the 11 characters. So how our this print for loop actually printing only the correct hello world and after no value after that. So because of that, when we are initializing these strings to the array, so after last character, by default the termination character is also stored at the next locations. Okay, so that A11 locations, and that is the identification of the termination. That means here our string is completed. So let's see, suppose if we add this termination symbol after this at this locations. Okay, So what will happen? So this location is 1 2 sorry 0 1 2 3 4 5. Okay, so let's just update this a5 equal to, and this 0. So this is actually a termination character. Okay, and what I'm doing, I'm just updating the character at this empty locations. Okay, this is now empty, and I'm assigning a new value, this /0. So what will happen? Our strings will print completely or not? Let's see. So s, and here I'm printing this a. So by loop, and let's see what happened. So you can see that now when we are printing this complete strings by the a. So once this is fine, okay, this /n is now we have received at the 5 index hello after this hello, and the remaining part is not coming. Okay, so this world is not coming because when we are printing using this, so this /n this is representation the termination, and our print statement is only printing this hello part. But here we are just using the, we are reading the all index. Okay, so after hello we are getting the same empty locations, but still our loop is running, and we are accessing the next element, okay, by the indexing. So we are getting the all elements, but this print statement is only printing the this part. But before that, when I, if I make this as a comment, so it will print the complete hello world. Hello world. Okay, so in this manner we can store the strings in our array, and we can access the each character, we can print the strings, we can perform some operations on the strings like this. So some basic operation we will discuss later. So before OPP exam, just try to complete all this array part. Okay, and later this week, Friday or Saturday, Friday we are planning to just discuss the mock questions, and Saturday session we will just discuss this strings and practice questions. Okay, so any query in this till now related to any topic? So OPP exam will be simple, so do not take much tension for this, because questions will be very simple compared to your assignments questions. Okay, and still compared to the mock questions also. So mock questions are lengthy and time taking, but the OPP questions will be easier compared to them. Any query, any question?
No, sir.
Okay. Okay, then we will discuss the other part in the upcoming session. Okay. So before that, just complete all this array and pointer arithmetic part and related questions. Okay. Then if there is no query, then thanks everyone.
Thank you,
Yeah,
sir.
thank you, sir.
Thank you, sir.
Okay. Bye. Bye.